Okay, I'm Gerd Stolpmann, and I would like to show you GODI today. And first, a few words about myself. I'm using OCaml since version 103 or something like that. So it's already for a few years, and in my previous job, I had the chance of working for 1 day a week, what I really would like to do, and of course I developed stuff in OCaml. It was a lot of fun, and this is the reason why there are so many libraries and tools for me, why that exists at all. And since a few years, I now work as a consultant, and I also had the luck to find OCaml-based projects, so I can really make my living from it. And also GODI started as a personal project. So we see here a timeline. 1996, OCaml came out. I think this is right? And quickly after that, I wrote my first OCaml program. I just discovered it. I've seen other versions of ML before, but then I discovered OCaml and found it excellent. And well, I wrote and acted lots of tools and libraries, and one of the first things I wanted to improve was FindLib, and so my impression was that we needed a way to make it easier for the user to use libraries and to link libraries in your final program. But FindLib was not the final thing. When new OCaml version came out, I didn't like that, because I had to recompile everything, and it was more and more going to be a pain. And that was one of the main reasons why I started to think about that, and the result is GODI around 2003, and this is already 5 years of development to now. Now we have about 110 packages in GODI, maintained by 30 people, and yeah, it's a kind of success story. So, so I already talked about a bit of my personal goals: make it easy to rebuild everything when a new OCaml version comes out, or a new fundamental library is released. And I also wanted to have support from multiple platforms. At the time I started GODI, I also used Solaris a lot, and Linux, and also a few other operating systems, also AIX and whatever. So one of the requirements that I wanted to support any operating system I had to deal with. And fortunately, this was only Unix-based operating system. This is one of the things that are still true. We cannot really support Windows right now. There's also a community effect, because GODI extracted a lot of packages. They added simply more software, much more than I could do for myself. The users have debugging. Also, the quality assurance was improved. For example, people figured out that on OS X some of the packages didn't work, and what could we do about it, and so on. GODI turned also out to be good for my business, because as consultant, you need always a reason to contact people, and when you have a thing like GODI, you can always say, hey, I'm the GODI guy. Can we talk about it? And yeah, so it proved to be useful for that. So installing GODI is really easy. There's a so-called bootstrap tarball. You can download it, follow the instructions. There are about 5 steps. All you have to do could be a bit more reduced, not right now, but it's has been traditionally a 2-stage bootstrap, and one could merge them into one, but it's not done. I don't want to show this. This is a bit, quite boring. More interesting is GODI Console, the central management tool. You can control everything you want to do with GODI. You can build, remove, or rebuild software. And I would like to show you a bit. So there are 2 modes. You can just start it without arguments, and then you get into an interactive mode. You can start it with arguments, and then then you have a lot of options. There are a number of commands. You can use this for scripting. For example, automating some packages or whatever. So this is the famous GODI console. You can simply, this is it's a text-based interface. It's simply because in professional environments you usually don't have the possibility to run X. I'm coming from that such an environment, and so it was never useful for me to have a graphical user interface. So, okay, you just pick one of these, whatever. Can build it. Okay, and it fetches the file, builds it, installs it, and then you have a new library. It's not very impressive. More impressive is, for example, what can I show? This is too long. For example, this might fail. Should have picked it before. Okay, we try this. And you see here, I've picked expat, and now GODI console has figured out that there is need to be another package, and so we have some dependency analysis built in. If I want to have GODI expat, and also need conf expat with this configuration package, tries to, because expat is a C library, and GODI expat is only a OCaml binding for it, and these packages, they try to find the C library and so on. And I don't know whether this works now. No. Finds it. Okay. Well, also, the sees is that, if I go here up, you see that checking user/user line, it tries a number of locations. So it isn't required that expat is installed a system-wide library. You can also have it, I think in Solaris this is in /sw, and there's also /sw, and another many locations are tested, so it works out of the box for a number of operating systems. Another thing that is quite interesting is you can also, for example, imagine there's a new version of PCRE, and I select it. Okay, and then GODI console figures out that there are a number of packages that depend on PCRE and must be rebuilt. And this is the automatism that is very user-friendly, because this is what I originally wanted to have. If I have a new version of anything, I would like to that recompiles everything that is built upon that. And so now I would just do that. So this is here an example. We have OCaml as a fundamental package. We have these PCRE bindings and maybe a user of PCRE that could be, for example, OCaml. So this is a hierarchy of packages, and we have two features in GODI that makes handling this quite easy. One feature is auto-completion. When I, for example, select OCaml and PCRE is missing, it is automatically added and also built. And we can also rebuild hierarchies. If, for example, OCaml is upgraded to a new version, everything that depends on it is also rebuilt. Would like to go a bit more into detail what package is, because it's not that complicated to make a package, and I would like to show you that. In GODI package we have actually two layers, shown here as these two boxes, and one is the inner box, one is the outer box. And the inner box is what comes from the author of the library or tool or whatever software it is. And this is simply downloaded and extracted somewhere. And what we need now is some wrapper around it that kind of GODifies it. So GODI knows this is this version, it needs this dependency, because dependencies are never in this downloaded original file. And a few other information are also required. And in GODI speak, one file is called the dist file, the distribution file, one is the build file. And actually the build file can be extracted to a small hierarchy with a make file, it is the info file, a plist file is still missing, and a few other things. And this format is derived from BSD ports. Originally, when I started with GODI, I simply took, I think, the NetBSD variant of this port system and modified it, and finally we had GODI. So this is an heritage from that, and it has never changed. So we will come back to the package format soon. We have seen GODI console. It's a user interface. It resolves dependencies and drives all the build. And GODI console is written in OCaml, of course. There's also a lower layer, which is not so nice. That's a problematic part of it. There's a tool called GODI make. This is basically a BSD make. Of course, written in C. It's a bit modified, but it's basically BSD make. The scripts are, of course, written in shell. We have also some framework files that come also originally from NetBSD, but are simplified. I think this BSD package MK file had originally about 8,000 lines of code, and now it's 2,000 or 3,000. So throughout most of it, but it's still a complicated thing. We have what's already done to improve this situation is that GODI make is rewritten in OCaml. It's no longer written in C. What we don't have yet is a better replacement for all the shell scripts. And if anybody has a good idea for this, I'm open for something better. But it must also be as powerful as shell. Shell is a very powerful language. So okay, GODI console and GODI make. There's two levels. GODI console makes a plan, remove this package, this package, build this package, and GODI make executes them for every package a set of scripts. It's always the same, and I hope you can imagine that. So when you make a package, it's not that complicated. There are actually two approaches, and I show here the approach that is built into GODI. There's another one, GODIVA, that also has some interesting properties. But first of all, this one. This is such a makefile that is the main file of this build tarbor. And you see that there are includes at the beginning and at the end, and these includes simply include the framework that is pre-built. And there are a number of variable settings. That's also not very complicated. And then there are you can of course also put scripts into it. For example, you can here add a post-install script, and because this is a make file, you can simply write it. And this is an example of a simple package make file. And by doing now make build or something like that, then this would do a package build or something. There's another part of the package, and this is the not so nice part, is the so-called package list. Package list is more or less a list of files that is finally installed in the system. And currently we have to write it manually. There are a few directives that makes it a lot simpler, so we don't have to write every file. For example, you can say, I have this library and I would like to include all its files, and then it's just one line. And you can also include hierarchies and so on. But what we don't have is an automatic tool to find out these package lists. The problem is here that we need some support from the operating system. That well, I said at the beginning I would like to have that GODI runs on many platforms, and this is an operating system dependency. You have to preload libraries and other tricks. You have to do other tricks to make package list automatism work. There's also disinfo files is totally boring. So, so when I have these few files, I can start testing it. Does it build? Can it be removed? Then I can check it in and release it with a web-based tool. This tool is also quite easy. This is one of the things of GODI users usually don't see, but the package managers. Packages have this. It's simply web-based. You check your files into a subversion in, and then you have this release tool, and then you can here select what release, and then it would say, okay, you have checked in these files. Would you like to release it? And then you say finish, and then they are rolled out to the public. So there's this alternate approach GODI by Owen Gundin and Wallace. And in this approach, you don't have a make file and a plist, but there's simpler spec file with only a few settings. What's the package? Who's the author? And so on. And mostly non-technical things. And but the requirement is that the package, as it is downloaded from its original place, must appear to some interface. It must be GODI policy compatible. As an easy interface, it requires that you can build a package with configure, make all, make opt, and build an installation must integrate prefix variable. And once you have that, you can use GODI, and then packaging is even simpler. And maybe GODI is at least a starting point for standardized OCaml software distribution. So maybe some kind of interface for the package, and not only GODI can use it, but also Debian or Fedora or whatever. GODI also has the option that you can run your own GODI server, because packages are only files on an HTTP server, that's all. You can simply make your own, put your build files and dist files to this directory. You need a file that is called available.new. Strange name, but it's historic reasons for that. And in this file, you have to mention all your package on the server, and then you have to set one variable, include your server into your configuration, and then the packages on this server merge with your packages from the official GODI site, and especially you can have new packages. You can have new versions of versions that are also on the official side, and yeah, that's it. So also a way to distribute software. GODI can also package non-OCaml software because, well, it is actually a kind of BSD port system, and GODI is well integrated into the operating system it runs on. It uses the C library it finds. There's an auto configuration tool, but you can also set the paths manually where maybe expert library or whatever it is. And this is implemented in these special conf packages and works quite well. We have some quality guarantees, maybe too hard word, but we try to provide all libraries and find the support. We would like that packages can be built on various system types. For example, there are also systems where there's no native code compiler, or you don't want to have it. There are systems that have PFS, no PFS support. There are no DLL support. GODI supports this. Makes it a bit more complicated than a software distribution system that runs only on one operating system. Well, we don't have not yet every package can be built everywhere. It's well, we need more testing. We need more quality assurance, and okay. But the future. This year we will have a new bootstrap architecture. Prototype is all available. It's a bit slow. It's not yet cannot yet build every package. We would like to reduce the dependency on software written in C. And here's the example that GODI make is replaced by something written in OCaml, and it's easier to maintain, and also for other people not not only for myself. And yeah, there's the big questions. Graphical user interface would be nice, would be really nice. There's the question, native Windows support. I think that it's only thinkable as commercial project, because it costs a lot of time. For an initial part, I would say 2 months of work, and then there's a continuous effort to keep your Windows packages in line with the Unix packages, and Windows users also need binary packages. I really cannot imagine that a Windows user compiles from source. It's not their style, and it's also a lot more complicated to set up a build environment on Windows. You have lots of things you can do, a lot of more things you can do wrong, because Windows doesn't come with a pre-installed build environment, and makes it all complicated. Yeah, that's I think the final slide. As I mentioned, 30 people. 2/3 of the packages are not maintained by me, but by one of these guys. New packages are always welcome. Well, packager needs some skills in shell and a bit basic knowledge about how things work. It's also good, and but we have also mailing lists, and there any questions can be asked and will also be answered. I see my role in maintaining the core GODI packages and the GODI system. So I will do upgrades of OCaml itself, and upgrades, and also develop the GODI console and GODI make and whatever core tools are required. And there's not much time left for doing more. So new packages, that's a matter of the GODI packages community. Okay, that's it. So any questions?
You already mentioned Debian packaging of OCaml packages. So my question is, how do you see possible sharing of work or cooperation with packagers for say Linux distributions? Because some of the problems that you have with building OCaml, with building GODI build scripts are of course similar to what has to be done to build a Linux package, but there are also things that are different. So at least I could imagine that it might be conceivable to have some common infrastructure or something like that that could help to cooperate.
Yeah, I also think that this is possible. I think there's this GODI approach, and I think this could be a starting point for an answer, because they GODI simply defines a package interface, and the original distributor of the software must implement this interface. So, for example, it must there must be ensured that make all really makes the software, for example. And GODI is an easy interface, and many software packages out there in the world, they also are already very close to it. Many don't, but there are, for example, there's the requirement to integrate this prefix variable. Many packages, software distributions don't do this, for example. So if they, yeah, I see that this could be a way to simplify packaging. So when there's software that sticks to some common interface, then there's a tool in GODI, tool in a Debian, just make a package of that, and there's no human intervention necessary. There's also a more complicated thing than when you want to use C libraries. This is hard to do. But pure common stuff should be doable.
In fact, as a Debian developer, I've tried to make some to backport your patch from CAML IDEAL, for example, where you have enabled a shared library in CAML IDEAL, and I tried to backport, and it's a bit complicated, but it's possible because you've got separated patch in your GODI packages. So it could be a way to share things between Debian, and because we've got D patches and you got simple lifts, but it also works. We could also share meta files for finding, because we do it twice. Yeah. But I don't agree with you, Godiva policy, in fact, because configure, make all, and make opt are standard C way of building packages. But you know, there's OMake, there's OCaml build, and a lot of things like that you will have to emulate to get a configure, make all, and a make opt. And even if it's too much C inspired, it's too much. Maybe something more generic is better. And another point is that you must not. You must make the difference between desdir and prefix, because in Debian we've got two different, because you always built in your environment, but in Debian we built in our environment, and we install in other environment. If you want to make a Windows port, you will have the same problem as us, is that you have to build somewhere and install another in another location of your file system, and it's totally different. So maybe I don't think Godiva. I think Godiva policy is too much restrictive. So it's just a remark.
Well, I said it's a starting point. What you can see there. What are the problems? Maybe solutions are not yet perfect and need discussion. More questions?
So as you said, GODI is based on PKG SRC from NetBSD, right?
Yes.
And it supports a lot of architectures, and I think it's not many as OCaml did. And do you think PKG SRC was the right tool to base GODI on, and did you consider any alternatives when you started GODI?
Yes. What was great about it is you start with a system that already works.
Mm-hmm.
Then you can really focus on the OCaml specific problems, and so this was good about it, that you had a quick start and get quickly to running software and quickly see what problems come up. And also good is that it is mainly a big script, and it's although it is complicated script and sometimes hard to read, and in some places it's also buggy, necessarily buggy, because they cannot do it better in script. But it is easily to modify, and easy to modify, and yeah, I think it was right to do so. Currently, I see that maybe this scripting also has disadvantages. It's a bit hard to maintain, and but we also don't need much maintenance there. So I think it worked, and that's a good thing about it. Any more questions?
I had a few questions.
Last question.
Okay. About cross compilation. About using GODI as a cross compilation, as a base for cross compilation. there anything?
This is really complicated. Don't know whether this works.